So today we're talking about the different views of origami tessellations. And when we're talking about this, often the first thing that comes to mind, whoops, sorry, that it's not showing what I wanted to show. The first thing that comes to mind is photos of the tessellation in different ways that you can look at the physical folded form. And the four kind of canonical ways that I've settled on showing origami tessellations is from the front, from the back, with and without backlighting. So these are lit from the front, and then you can shine light through the paper and get more detail about, okay, where are the layers in this pattern? You can look at that same light shining through the paper from the back. You can see a detail shot of the particular pattern. But what I want to talk about today is less about photography and more about the conceptual frameworks underlying the pattern. So when we have an origami tessellation, these are typically, oh, and I should mention this pattern is called serrated. It's a pattern that I folded during a live stream. You can check that out. If you search serrated on my channel, you'll find that. The typical way of communicating these patterns is in a crease pattern. So this is typically as much documentation as you'll see on an origami tessellation, where we have all of the folds that will eventually be in the final pattern drawn out on a background grid. And this is only useful if you can recognize, yes, this is a double depth closed hexagon twist. This is an open trapezoid. This is a closed rhombus. And this is a double open triangle. So if you can recognize all of the twists in the pattern, then you can, and by the way, for this pattern, 3 of those twists are on the back, the closed shapes with all the same coloring of the lines. And I use solid red lines for mountain folds, dashed blue lines for valley folds. You could read it the other way around. It would swap your twist directions, rotation directions, but you could read it the other way. But being able to recognize, okay, we've got these 3 twists, and that's relatively clear because the new folds around the twist centers are not on grid lines. But then this one in the middle is also a twist. But then say this thing where there's a valley, then mountain, then valley, then mountain, that's not a twist. That's a space in between pleats. And in order to decipher this crease pattern, you have to be able to recognize all of these different parts. Or in my patterns, I'll annotate them. And this one is more thoroughly annotated than I usually do. Usually it's just the black lines and black dots on each of the twists. This one I worked up a little extra special for a convention book. But here, it's very explicitly saying, okay, well, you've got blue dots in the hexagon twists, green dots in the trapezoid twists, purple dots in the rhombus twists, gold dots in the triangles. And these black lines are saying these 2 shapes are connected by a pleat. And so you can start seeing, okay, I've got this hexagon, it has 6 pleats, and all 6 pleats are going to trapezoids. My trapezoids, the pleat opposite the one from the hexagon is going to a triangle, and the other 2 are going to rhombi. For my rhombi, all 4 of my pleats are going to trapezoids. And for my triangle, all 3 of my pleats are going to trapezoids. So you can start breaking down the pattern into its component parts and saying, okay, I have a hexagon, a trapezoid, a rhombus that connects back to a trapezoid to the hexagon. That's one loop. And then the other loop that's present in the pattern is rhombus, trapezoid, triangle, trapezoid, rhombus. That's the other loop. And every single part of the pattern is part of one of those two loops. Either the loop has a hexagon or the loop has a triangle. And the other parts of the loop are trapezoid, rhombus, trapezoid. That's what's going on everywhere in the pattern. And then there's this additional marking that says from the central hexagon to the trapezoid, there's a gap of 2 grid spacings. Those are all the details that you need, in addition to like which hexagon, which trapezoid, which rhombus, which triangle, to describe the whole pattern. And so this is what I would call an annotated crease pattern. If it didn't have the colors on the dots, if it didn't have the spacing, that would be what I call the skeleton form of the crease pattern. And then you can take these colors and expand them and look just at the shapes. So taking away the crease pattern altogether. Here we have a tiling. This is another view of the same pattern, but it also describes a lot of other patterns. So the tiling is more general than the crease pattern, than the folded form. It's not saying specifically what hexagon, what trapezoid, what rhombus, what triangle. It's just saying there are these shapes and this is how they connect. And when they connect, you see we have the hexagon, trapezoid, rhombus, trapezoid back to hexagon loop. We have the triangle, trapezoid, rhombus, trapezoid back to triangle loop. And those are the only 2 loops that we have in the pattern. That's exactly the same as we saw in the annotated crease pattern. Here you get to see, okay, which pleat of the trapezoid goes to the hexagon? The double depth pleat. Which pleat goes to the triangle? The middle of the 3 single depth pleats. When we have a longer edge in the tiling, that corresponds to more space between the mountain and valley folds of the pleat. And we can see some really cool things in the tiling that were not apparent at all in the crease pattern. Namely, the tiling breaks. So these are the stopping places while folding, where you will not have any pleat overlaps. And you can see me apply these tiling breaks in the case of serrated in that live stream from last summer. So obviously around the central hexagon, there's not going to be pleat overlaps. But then when you add in 6 trapezoids and 6 rhombi, there will also be no pleat overlaps, because in the tiling, what we're thinking of is the pleats are leaving these shapes perpendicular to the tile boundaries. And so if 3 pleats are all leaving the same edge perpendicular to the same line, then they're parallel to each other. So a little bit of geometry lesson on your Tuesday morning. And then this line, this is the interesting one that goes halfway through each of the next bigger hexagons. This line tells you, hey, you can also stop at this point. Just have 2 pleats going into this great big hexagon. One, well, it would be a triangle wrap because there's a triangle remnant of this rhombus. Some kind of 3-way intersection triangle wrap setup for the rhombus. That is a good stopping point too. So this was kind of a key breakthrough when I started recognizing that you can just draw a hexagon on your tiling and just cut off the shapes that hang over the edges. And that has a folded representation too. And that is a good stopping point. So you're not doing 1, 2, 3, 4 layers of twists, which means having basically 4 pleat overlaps that you're moving across a set of parallel pleats. And you got to get all of them all the way across to get to the other side, to get to no pleat overlaps again. Here you just have 2, and then 2 more, and then you have a layer where it's just 1 pleat overlap moving all the way across. So these different views really inform the folding process. You really can't see the tiling breaks on the crease pattern. Like if we tried and pick that out, we would be saying, okay, central hexagon, okay, I believe that if I fold just the central hexagon, I won't have any pleat overlaps, kind of in the definition of a single twist. There's no pleat overlaps from a single twist. But then if you go out and you say, well, what boundary line can I have where there are no pleat overlaps? They're like, well, all the straight lines cut through twists. And so if you're looking for something, like maybe you see, okay, there's this line here-ish, but it kind of falls apart. You don't really get to see that if you have the trapezoid and rhombus folded around your central hexagon, then you have a pleat up, and then this one, pleat up, and then pleat over, pleat over, pleat over, pleat out, pleat out, pleat out. And so there's a lot more confusion in the crease pattern about where those stopping points are. So the crease pattern's great at telling you what twist to use and how far apart to space them. Terrible at telling you where to stop folding the pattern. Also, hi everyone in the chat. Glad to see y'all are here. And so I use the crease pattern to figure out how much grid I need and to start folding the pattern. But that's it. So if I were to open up, and by the way, I'm using the tiling to decide how much I want to fold. So for the case of serrated, where I folded out to just past the 3rd ring, so I've got 3 layers of repeats. I was saying, okay, I want to get past the tiling break that's after this full repeat. And so what I would do there is open up my crease pattern, and I've got it drawn out on 64 divisions here. And I can say, okay, here's my central hexagon. Here's the first layer of hexagons around the center. And then I want another layer of hexagons around. So let's pretend that actually this one is my center. And then this is the first layer around. And then this is the second layer around. And then I want to make sure to get past these rhombus twists and that trapezoid, because those are included. If I want full repeats around a particular hexagon, I need those rhombus twists between the trapezoids, and I need 1 trapezoid of the next layer of hexagons. So that's what I'm getting from the tiling. And then I can say, okay, I want to have my grid extend at least past here from this starting point. in the center, and then I can count my way out. The other thing that I use the crease pattern for, and I'll actually have to open the SVG form, I use the crease pattern to calculate the rotations of my grid. So in this view, I've got a whole bunch of different layers. The skeleton is that layer I talked about where you just see the black dots in the twists, and that is what comes standard in all of my crease patterns. You'll see just the raw crease pattern, and you'll see the crease pattern with the skeleton. And then I also have a layer where I determine, okay, so I'm looking at this line here, from one big hexagon to the other big hexagon, center to center, how many grid spacings am I going? And I'm counting that along one grid direction and then along the other grid direction. And then I'm plugging those numbers in to a formula that I mathed out a while back. Basically, we have the count in the first direction, the count in the second direction between those two repetition points, which, by the way, I verified in the tiling that these repetition points are aligned with the tiling breaks. You can also see they're aligned in the same column. That's the same geometry. And so I'm using the tiling to say, okay, these are the points I want to be aligned in the pattern. They have this measurement on the crease pattern and on the background grid. And then you plug in these numbers. So X is 3, Y is 14. The formula is Y divided by X plus Y for triangle grid. Super simple. So 14 divided by 14 plus 3 is 17. And then you can sometimes simplify. Sometimes you can just fudge the fraction where it's like, well, this is basically 7/8 or 7/9. If I wanted to be super precise, I would actually fold it as 14/17, but that's a bit of an annoying number. So for this pattern, after looking at the crease pattern, getting the number of divisions for the specific number of repeats, making sure I'm getting out past that next trapezoid, which in this case, not very far past, it ends precisely at the corner of that trapezoid. Then I was able to make a custom rotated grid for this pattern because I had the crease pattern and because I was looking at the tiling and saying this is where it should stop. And then I was able to get this kind of result from the crease pattern and the tiling used together. So one thing that I want to play with today is taking a look at what do you do if you don't have the annotations for everything already. So I'm gonna pull up random photos on Flickr. So I just searched Flickr Origami Tessellation. I'm gonna go to the Origami Tessellations group and go to the photos. There's 15,000 photos. And oh, cool, including some new ones that I have been seeing posted over the last couple days of Advent of Tess patterns. Actually, a lot of these on the first page are Advent of Tess patterns. So if I'm looking through here and I want to figure out, for example, let's go with this pattern. because that's cool and I haven't seen it before. So we've got this pattern and we want to figure out what exactly is going on and maybe reverse engineer it. And we don't see the tiling for this. So I'm going to look through. Luckily with this pattern, they did post the backside. So we do have that piece of information. But we can take a look here and say, okay, what's going on? What shapes are being used? And I'm going to go ahead and bring up a blank document in here. I'm actually going to bring up a custom document and we're going to try and get the tiling of this pattern. So this will be an iterative process. We'll be figuring this out one bit at a time, and can have this guy over here. Good. So the first thing that I notice in here, and maybe, okay, already maximum size. So the first thing I notice in here is that we've got these 6 shapes around a closed hexagon, and it's alternating rhombus and triangle around a hexagon. So we can take over in our shapes a rhombus, a triangle, and a hexagon. And I'm going to color these. So let's see. With this guy, looks like the hexagon is right-handed. I can see it rotating around in a right-handed way. And let's see. There we go. Now I can see what I'm doing. And so I'm going to make that hexagon red. One of the rules of the tilings is that they need to be 2 colorable. And while I'm here, I'm also going to take a look at what shape is between the rhombus and triangle that we saw on the other side. So between this rhombus and triangle, there is a triangle on the back. And so I can say, okay, this guy is going to connect like this. So there can be another triangle that is right-handed between them. Although we'll see in a minute, it doesn't make a huge difference which way I've rotated it, because the other side between the rhombus and the triangle, so between this rhombus and that triangle, there's a hexagon. So yeah, it's a lot going on. But one of the things I can specifically say is that these rhombus and triangle twists, so rhombus on one side, triangle on the other, they're making a loop around a position of symmetry that is 3-fold rotationally symmetric. So I'm going to go ahead and drag these guys over here to make it really clear that that's a loop of 6. And then the other thing going on in this pattern is those great big hexagons on the back. So that's going to be another right-handed hexagon. And I do believe that's the whole pattern. Oh, cool. So that is actually a tiling that I just recently designed something in. So now we can propagate the pattern. One of the really cool things about this tiling is that you can imagine that it was an alternating hexagons and triangles tiling, but then some of the groups of hexagon with 6 triangles around it got turned into, so a hexagon and 3 of its triangles got turned into 3 rhombi and 3 triangles. This is a tiling that I have started playing with. I think I call it false star. My system has a lot of, there it is. So you can see this is the same tiling. And I'm going to share a crease pattern that I just recently designed that I haven't folded yet. So this is another pattern in that same tiling. And we can see some similarities and differences between this pattern and the one that was folded. Oh, awesome. So I'm seeing in the chat, yeah, Flickr is an awesome resource for figuring out, well, for seeing the variety of patterns that are possible. And yeah, there's so much to learn with the origami tessellations. So conveniently here, I already have a crease pattern. I wouldn't want to like necessarily go and make a crease pattern for someone else's design and share it publicly. So I'm glad I have my own here. And there's some slight differences between what I have and what they have, but it's actually all of the twists are on the same side. All the shapes are on the same side between my pattern and theirs. And actually, let me see what the name of this person is. Matthias Schwar. So yeah, very cool pattern. Radiance, says pattern. Has these flagstone motifs on both sides. Very cool. This pattern basically uses closed twists instead of open, and that's the difference between the two. And this one has an extra space between the twists. So all of these blue twists in my pattern are closed, and this open hexagon is open instead of double open. And that's the difference between these two patterns. But we see the same features of a closed hexagon, a bigger hexagon, and a loop of alternating triangle and rhombus twists as our 3 positions of 3-fold rotational symmetry. And I can actually go and be more precise about how this pattern was folded. So I'm looking at it and I'm seeing it's folded all the way to the edge and on a standard grid. So I'm looking at this edge and seeing that that is a straight grid line. So if I wanted to plan this pattern, I would take a look at the tiling and say, okay, what point do I want to be the center? And I would probably pick the loop of alternating rhombi and triangles. because that is going to make things look the most hexagonal in the end, at least on the tiling, as much as it can be. So if I have this in the center and I'm working out and out, I'm hitting sixes of things, which is broadly what I want. And there would be, you know, a discussion. Do I go out to this point? Do I go out to this point? Maybe to here? Maybe out to here? Probably out to there would be the nicer stopping point. And then I do have these tiling breaks that are cutting through the rhombus twists, but that's fine. So let's say I want to have, okay, so the repeats of this center are going to be anti-aligned to the tiling breaks. And so I can take that information and say, okay, I have, oh, convenient, past me thinks the same as current me. I have this in the center, and this is my distance to the next repeat. But what I want to actually have lined up with the edge is this sequence of the 3 different positions of threefold rotational symmetry. So that's going to be 2, 4, 6, and 1 spaces. So 1 over 6 plus 1, 1/7, which is far enough from aligned that I would take the effort to fold it on a rotated grid if I was going to do, you know, a lot of repeats. And then with the tiling, I said I wanted to get past the first hexagon after the repeat in that direction. So 1, 2, repeat, first hexagon. I'm going to be looking at 64 divisions with my rotated grid. And so with that, that's going to cut through kind of, mostly aligned, but partly not. Kind of this way. Yeah, this direction. And so, yeah, that's my cut. So having 64 divisions out to here and then my rotation direction, you could honestly do this one on an excuse me, on an aligned grid and get a decent border. And with that, I would be turning this rhombus into a triangle. I would be turning this rhombus into a triangle. That triangle's not going to get folded. Yeah, that triangle's not going to get folded. This one's going to continue out to the edge. That triangle's not going to be folded. That one's going to turn into a triangle. And so I would get even a decent border with 64 divisions aligned. So that's what I'm really using the crease pattern for. Figuring out what grid to use. And then in the initial setup, I'm looking at, apparently I'm as zoomed in as I can be in the PDF reader. I'm looking at, okay, 2 spaces from the center. This triangle is right-handed. And then getting that loop of 6. And then, so once I have the loop of 6, that'll have 3 pleats out in these directions and no pleats in these directions. And after that, I want to add in the 3 triangles and these 6 hexagons and these 3 triangles, and leave these rhombus positions as 3-way intersections. So getting that tiling break around those hexagons. And it's less about adding in the triangles than the hexagons than the outer things. It's more about starting at a particular location and working my way around. And then I'll add out another layer. And in this particular tiling, I would say adding layers so that the hexagons are complete is probably the best move. And then you'll have a lot of 3-way intersections for rhombi, but you won't be dealing with 2 and 3 pleats going into a hexagon. So that would be my recommendation for folding this pattern, using these different views of the tessellation to inform the folding process. So that was one pattern off of Flickr. Let's go ahead and pick another one. And I'm gonna scroll all the way down. Lots of great patterns on here. And I'm just gonna pick a random page, scroll down, and pick one. This is one of Miguel Gagnon's tessellations, and it's named Split Hexagon Dance. What I'm seeing, I just zoomed in, what I'm seeing in this pattern is that it's not strictly using only twists. So there's hexagon twists, and then there's these 3-way intersections that have been laid down flat. And if I cut this chunk, that describes the entire pattern, because the boundaries of that chunk are mirror symmetry lines. So what we've got here is a pattern that's actually extremely closely related to one that I taught recently. He just doesn't have the triangles squashed. Let's see. Disintegration. Conveniently, I taught it with the mirror symmetry lines. And yeah, this is a nearly identical arrangement of pleats, but we've squashed the triangles in disintegration, which is a pattern that dates back to Shuzo Fujimoto. And so the tiling on that is hexagons and triangles threefold. And you can see the structure there. It's still hexagons and triangles, but the hexagon pleats are connecting to each other on 3 sides. So you can kind of imagine this pattern continuing outward and outward, where this center is repeated on each of these groups of triangles. You can verify, like, the bottom 2 triangles of the center match colors with these 2, likewise these 2 match with these 2, etc. And so we have this grouping of a hexagon thing with 3 triangle things around it that's then mirrored everywhere, which is exactly what's going on in this pattern. And the difference is, instead of that three-way intersection being an extra space out and folded so that the pleats are squashed, or so that the twist is squashed, we have a little bit of extra space produced in the middle by backing those pleats for the triangles out from the center. So there's now 3 spaces. So 1, 2, 3 spaces between the three-way intersections instead of the 2 spaces that we see in disintegration. Bring up the crease pattern for that. So here there's 2 spaces between centers of triangles. The vast majority of the crease pattern, and in particular the spacing of the hexagons, is going to be the same for Miguel's pattern. It's just that we're not squashing the triangles and we're spacing those three-way intersections further apart. So that's a cool one. I'll reset the zoom on here and go back to the photo stream. So when you have this mindset of analysis of the patterns, you can really dig into what exactly is going on. That's going to be a fun one to analyze. Okay, so it's a design by Joel Cooper called Elongated Rhombuses. And what's going on here, and what happens in a lot of these flagstone patterns, is that the shapes that you see don't necessarily match the shape of the tile. So this pattern, we only see the front side, but we can do a good analysis on this. We can say, okay, we've got a hexagon in the middle. There's 6 pleats coming out of that closed hexagon hole. And actually, ooh, we can zoom in. Excellent. But moving my mouse moves the whole pattern. Okay, poor design. So when we have, I wonder if, yeah, okay, I can put my mouse at certain points. So in the middle there, we have those 6, what looks like rhombus twists around a central hexagon. I say what looks like rhombus twists because I see there are some interesting things going on at the pleats, particularly where I have my mouse. There are 2 corners of these mixed depth rhombus twists that, instead of having a single pleat come off of them, they kind of come in and then they spread out underneath. So I just moved my mouse off of that spreading out. So there are quite a few more pleats coming out of that hole than you would expect from a triangle. And I would have to really look and figure that out, exactly what's going on. But I can say that the end result is there are 4 things coming out of that. And so at a minimum, that is going to be a rhombus in the tiling. At a bare minimum. It might be a trapezoid in the tiling. I'm not sure. And then, so we've got those mixed depth rhombi around, that's going to have to be a double depth triangle in order to accommodate the double depth pleats. One of the reasons I can say that is because this pleat is coming down off of that corner, which means that the mountain and the valley fold for this edge are 2 spaces away, so that's the double depth edge. And so let's try and construct this. Let's stick this over here and bring up our tiling workbench. And I'm actually going to bring up a new one. Just to have fresh shapes. There we go. And I'm gonna start by drawing the shapes that we need for this. So this pattern is going to have a double depth triangle. I'm going to draw that in the same style. And it's also going to have a mixed depth rhombus. And it's also going to have hexagon and rhombus. Okay, so we've got hexagon, rhombus, these elongated shapes, and I'm going to start actually with the mixed depth rhombus and the double depth triangle. I'm noticing that I drew my rhombus in the opposite orientation of the one here. So now the mixed depth rhombus, technically a parallelogram that my mouse is on, is matching the orientation of the one in the tiling. Oh yeah, yeah, these twists are definitely difficult, especially with that spacing, and I'm gonna guess that a lot of this was air folded. So here we have this twist, and we can rotate 120. And let's see, can I see it? Okay, the triangle is right-handed. Because I'm looking at the mixed depth rhombus, and particularly that one pleat that's heading into the triangle, and saying, okay, that's a left-handed twist. So I've got that arrangement for my my mixed depth rhombi. With my hexagon, it's a little tricky here with the hexagon because the way the pleats come out of the rhombus and the way that the rhombus tile is interesting, shall we say. But we're gonna have these rhombi either in this orientation or that orientation. One of the two. And then we've got these two unidentified shapes that are helping things come together. Right here, that is very interesting. It might not be very easy to summarize with the tiling, because there's that splitting of the pleats at the corners of the mixed depth rhombus, which is like kind of a functional triangle right there at the corners before you get to the squashed triangle twist underneath. Like these things are all squashed as triangle twists, but that doesn't mean that that's what they are in the tiling. Flagstones do some interesting things. But what I can say is that this is going to duplicate and have a 60-degree angle and then touch like that. And again, this chunk, we're not sure exactly about the rotation yet, but I am very certain that these two tiles touch corner to corner because there is a loop around a flat space between pleats where my mouse is. There's a loop of 4 twists. So that much I'm confident of in the tiling. And I can take these and repeat them again. And again. And then this guy kind of slots in there. So there's some real funky stuff. And it feels like there needs to be more space. But the important thing here, I think, is that there's some weirdness happening in these places where these twists are coming together. And perhaps there's more weirdness in here than just 2 tiles touching, because this is kind of using half of the space here and half out here. So if we had that grouped, no, not Control F. And then rotate and stick it halfway out, maybe? That might be the more accurate thing to do in this situation. But actually getting it to stick, there we go. That might be, no, the other way. Might be a more accurate representation of what's going on. It's very weird, but then flagstones are weird. Right. That feels like a more stuck together representation. Should be more exploded. There needs to be more red bits in the middle. But anyways, And this is the broad strokes of how the pattern works. Yeah, there's some weird stuff going on. I'd be willing to bet, actually, that there's some form of rhombus going on in there. And then if these guys come in, that's probably the more accurate tiling. And there's something going on. Okay, so I'm seeing the parallelograms on the boundary of triangle don't sit at the boundary, but they enclose the triangle. Yeah, the interesting thing is when you go from a folded form to a tiling, it's not going to look exactly like the folded form. And so there will be some weird things going on. And actually, maybe this would be on this side of it. Let's see, do both of these, yeah, both of those do interact with that. So maybe these are more of trapezoids. But really weird trapezoids. And then we can copy those around. That seems to be roughly what's going on here, because there's two of these weird notches that are kind of adding additional triangle-y things to the actual triangle that is folded there. And that one's got to be some kind of weird shape as well. But the bottom line is, some things are more mysterious than they appear. And this one, I mean, you could test it, but I would kind of expect very little drift between the repeats and the tiling breaks. You're not going to get good tiling breaks, but you might actually get one good tiling break outside of the first set of these parallelograms around the triangles. Maybe. So that's kind of what I would bet on in this situation. The other tricky thing here is that these things that look like rhombi, because they've got that split point, I don't know that I trust that they're actually rhombuses. I think maybe the more accurate representation of that is a trapezoid also. So if which would kind of solve my problem a little. So if that is a trapezoid, and that is a trapezoid, then we would have some kind of, would have to be a mixed depth rhombus in here, which we don't precisely, well, don't precisely see in the crease pattern, which is weird. Okay. This is a valid tiling that would work for things. It's going to be a royal pain to design in, but it would work. And mostly I say it's going to be a royal pain because the symmetry points, like this is not precisely what's going on over here, because there's no actual twist in that position of twofold rotational symmetry. So I know this is slightly off, but I don't think it's far off. So, yeah. Okay, we found one that stumped me. And if I go back to the photo pool, there's all kinds of cool things that can be analyzed. Like this one is triangles on opposite sides. This one, there's some square things, there's some kind of triangle-y things in boxes that then are mirrored. Okay, so the question is, how am I doing the tiling? When I'm looking at the tiling, I'm trying to figure out, and I'll bring back our original crease pattern and tiling. I'm trying to figure out what shapes the twists are in the pattern and how they're connected. So with this hexagon twist, it has two spaces between the parallel mountain and valley folds of that pleat, and it's going, so it's connecting to the double depth pleat of the trapezoid. So I have a longer edge on this hexagon connecting to the longer edge of the trapezoid over here. And then on the opposite side of the trapezoid of the hexagon is the triangle. So hexagon, trapezoid, the pleat that is the opposite side goes to the triangle. And in the crease pattern, you can see that the triangle looks at least as big as the hexagon. But in the tiling, the triangle is a lot smaller. And that's because the only thing the tiling cares about is the direction and size of the pleats. So the direction of the pleats for the triangle is 3 directions. The size is a single spacing. So we've got 1 space between parallel mountain and valley folds for the triangle twist. With the rhombus twist, we've got 4 pleats, 2 pairs of parallel directions, single space between twists, or sorry, between mountain and valley folds. So we've got this rhombus shape with a single space on each side. With the trapezoid, 3 of those sides have the single depth pleats, and the other has the double depth. So that's how I'm getting from one to the other. It's a little harder with the flagstones because they do weird things with the corners of the twists that functionally add triangles to the tile of whatever shape is on the other side. But there still has to be some kind of map of basically how all the shrinkages in the pattern match up with each other. That's what the tiling is, a map of how the shrinkages in the pattern match up with each other. Which also tells us interesting things about when those shrinkages are heading off in parallel directions. So I think that comes to a conclusion of our explorations here today. Otherwise, I'm just gonna go off on a tangent and keep doing this all day. So that is where we're at. And then let's say, for example, if I wanted to design a pattern that uses this tiling, the approach I would take is, so let's full screen that. The approach I would take is figuring out, okay, what mixed depth rhombus do I want around what double depth triangle? And then what mixed depth rhombus do I want between them? That will set up my symmetry points. And then I need to figure out, okay, what pair of trapezoid twists works with that? And then what hexagon twist fits in the middle. For this one, I would not go from the inside out because the center of this rhombus twist and the center of this triangle twist have to have a very particular geometric relationship in order for the symmetry of the pattern as a whole to work. So I would not try to get to that relationship by chance. So I would be extremely intentional about exactly what I was putting there and whether it's a friendly mixed depth rhombus or not. So that is kind of the conclusion for this tiling, and kind of feeding into the design aspect of all of this exploration, where we can not only use tilings and crease patterns to fold from, but we can also use this idea of tilings to say, okay, I know this layout of shapes is possible. Now let me design an origami tessellation based on that. So that's what's going on with the different views. They each tell us something a little bit different about the pattern. And we can use pieces from the crease pattern for planning the grid, for starting the folding, from the tiling for also planning and figuring out where do you want to stop, but also where do you want to stop on the way as you're going through a pattern. Like let's say for this tiling, I was able to say, hey, I want to center this here, because then as I expand out, I get to add a layer of hexagons every time. It would also be true for other starting points, but this one's going to feel, I think, more symmetric starting in that position. One thing to keep in mind is these two hexagon positions have different twists in them. So it's not going to feel all the way symmetric, but it's going to work out. So that is what we're talking about with the different views of the origami tessellations, and seeing like, okay, we've got the folded form, we've got the tiling, we've got the crease pattern, and all of them are beautiful and all of them help us fold beautiful things. So happy folding, everyone, and I'll see you next week.